So here's that cheetah again, going back and forth, back and forth. So the patterns is what we're focusing on once again today. Patterns of repetition and trying to understand those patterns. All right. Good morning, gentlemen. I know you can't see me too well, but that's fine. I want you to focus on this. So this week, the big concept is how do you convert a repeating decimal to a fraction and therefore prove it's a rational number? Um, so yesterday during our Zoom meeting, a trick kind of came out. Mr. Adams Morgan brought up something, and then a couple people started to pick up on it. And I wanted to share that with you today because I think it's a nice way to look at how to convert a repeating decimal to a fraction that's a little quicker than doing the systems of equations method. Um, the systems of equations method is important, but this is a different method that's a little faster, and it won't help you solve every problem, but it'll help you solve a lot. So I was telling the story about when I would, shoot free throws in my driveway growing up. This is me. My Zoe just looked at it and said, "Is that a boy or a girl?" And then I said, "It's me." And she said, "Why are you wearing a dress?" But let's just pretend it's me. Um, so I wasn't very good, and keep track of my shot. So like I missed the first shot, so 0 out of 1. All right, so everybody knows that's 0%. Then I was 0 out of 2, missed the second one. All right, so it's still 0%. Then I made the third one, so now I'm 1 out of 3, and we know that's 33.3 repeating percent, right? That's a repeating decimal, and which also proves it's rational, right? Because I can write it as a fraction. So 1/3. So now I'm shooting 33%. So I went from 0%, I jumped all the way up to 33%. Then I missed the next shot, 1 out of 4. So now I'm down to 25%, right? 0.25. Then I made the next shot. Now I jump um, up to 40%, right? Because 2 out of 5 is 0.4, 40%. Um, then I just keep missing the next couple of shots. And then eventually I'm 2 out of 9. Now, 2 out of 9, that's one that you don't typically memorize. But it turns out it's a repeating decimal. And this is the pattern that somebody noticed because when I jumped to my next shot and I missed the next shot, I was 2 out of 10, which we know is 20%. So the question is, if I know 2 out of 10 is 20%, then when I was 2 out of 9, what would that percentage be? It has to be slightly bigger, right? Because when I miss the next shot, my percentage should go down. So when I was 2 out of 9, it should be higher than when it was 2 out of 10. So 2 out of 9 has to be a little bit bigger than 20%. Now, those of you who have memorized that know that it's 22% or 0.2 repeating. And when I was telling that story, Mr. Adams Morgan picked up on this first, and then some other people started to pick up on it as well. That wait a minute, there's a pattern here to these repeating decimals, and he's exactly right. And this is it. So I call this the Zoom trick. All right, maybe you can't read that too well, but it's the Zoom trick for converting repeating decimals to fractions. I call it the Zoom trick because we came up with it during the Zoom conference. So we start off with something very simple. Uh, these are things you know, right? 0.8, you can write that as a fraction because this is 8/10, right? This is in the 10th spot, so you could write that as 8/10, 8 out of 10. 0.51, you could write as 51 over 100, right? Because it's in the 100 spot, so you have 51 out of 100. If I went to the 1,000 spot, right? If I had 13 thousandths, then I would write that as 13 over 1,000. So we're converting these terminating decimals. I know they terminate because there's no line to repeat. I convert these terminating decimals. It's fairly simple, right? You know how to do this. You look at the place value and you put the place value in the denominator and you put the number after the decimal in the numerator. Same thing if it was a mixed number. 2.7 would just be 2 wholes and 7/10 because it's in the tens place. 51.37 would become 51 and 37 over 100 because it goes to the 100 spot. 4.125 would become 4 and 125 over 1,000. Now, hopefully, you could simplify a lot of these, right? Here you could put 5 goes into both. This eventually simplifies to 1/8. This you can't simplify because nothing goes into 37 and 100. This you can't simplify because nothing goes into 7 and 10. But you could convert them to improper fractions. But the point being is that for a terminating decimal, it's fairly simple to convert to a fraction. We've seen this. You've done this a number of times. We even watched that video on Tuesday. So the question is, what about these repeating decimals? So Mr. Adams Morgan started to notice this particular pattern, that 8/10 is 8 over 10. And we know that's 0.8000, right? The zeros keep going. There's a 0 after the 8. If we don't write anything, we assume the next digit's a 0. So 0.8 is really 0.8000. Or you can write that as 8/10. And what we noticed is, if you want the 8 to repeat, you simply decrease the denominator by 1. So here, to write 0.8 as a terminating decimal, or 80%, you would simply write 8 over 10. Here, you would still write the 8 in the numerator, but to make it repeat, you decrease the denominator by 1. So 8/10 as a terminating decimal is 8 over 10. 0.8 repeating as a repeating decimal would be 8/9. If you had 0.5, we know that's 5/10. But if I have 0.5 repeating, that's going to be 5/9. Again, 5/10 means it's 0.5 and then all zeros. 5/9 means it's 0.5 and then the fives keep going. So this is a slightly bigger number, right? If I made 5 out of 9 shots, I'm shooting about 55%. If I made 5 out of 10 shots, I'm shooting about 50%. Same thing works for the hundreds. 0.27, we know, is 27 out of 100, or 0.27 and then zeros. But if it's 0.272727, you would write 27 still in the numerator, the thing that repeats, but instead of 100, because it goes to the 100 spot, you would do 1 less, 99. 27 over 99 is 0.272727. So this is like 27.2%, and this is 27.0%. Really, really close, right? Almost exactly the same, but not exactly the same. But again, the trick is, how do you convert a repeating decimal to a fraction? Well, this is a lot simpler than doing that systems of equations method, although that method has its very important use later on. For here, 3.45. Well, that's 3 and 45 out of 100. But if I want the 45 to repeat 3.454545, it would be 3 and 45 out of 99. Same thing works for the thousands. 0.215, we know, is 215 over 1,000 because it goes to the thousands place. We assume the next digit would be a 0. But if I have a repeating sign over that, the way to write that would just be 215 over 999, 1 less. And maybe if you remember the activity, what we saw in Khan Academy and what we saw the previous day on Tuesday, you realize why it's 1 less, all right, because of that systems of equations. But it works every time. 3.168 is 3 and 168 over 1,000. But if I want the 168 to repeat, it would be 3 and 168 over 999, meaning this is 3.168168 as opposed to 3.16800. This is a tiny, tiny bit bigger than this. So I wanted to share this with you because the question yesterday was, or the pattern that we came up yesterday was a nice little trick that I thought everyone would like to hear. So go ahead and answer the questions coming up.